Hello everyone, so today in this video we are going to solve a question of LeetCode, that is kth largest element in a stream. This is 703rd question on LeetCode and this comes under easy category. Alright, so let's start with the problem statement. Design a class to find the kth largest element in a stream. Note that it is the kth largest element in the sorted order, not the kth distinct element. Implement kth largest class. So basically we need to declare a constructor here which initializes the object with the integer k and the stream of integers nums, and second we need to initialize a function where append the integer value to the stream and return the element representing kth largest element in the stream. Alright, so basically we have given few elements and we need to implement these functions. Like first one is a constructor and second one is a function which return a value integer, and this integer must be the kth largest element in the array. So let's see the first example. In the first example we make a comment here, and yeah, so in the first example we have k equal to 3. So let's take k equal to 3 and we have given an array that is 4, 5, 8 and 2. So the array given here is 4, 5, 8 and 2. Now we add an element into it. Let's say we are adding 3. So if we add 3 into this, so now you need to find the third largest element because k is 3, so we need to find the third largest element. So to find the third largest element, what we will do, we will first sort the array into non-decreasing order. This is basically a brute force approach which we are following right now. So the brute force approach is that we are sorting the array. So after sorting the array in descending order, we will get 8, 5, 4, 3 and 2. Now the third largest element is 4. So we will be returning 4 in this case, as it is given here. We are returning 4. Now let's see the second example. Second case. So in the second case we have 5. So let's push 5 into this. So after pushing 5 into this, the sorted array will become something like 8, 5, 5, 4, 3 and 2. Now the third largest element is 5. So we will be returning 5 from here. Similarly, we can do for other cases too. So the time complexity of this brute force approach will be around n log of n because we are using a sorting function again and again here. Alright, so to optimize this approach, we can use a min-heap. So in min-heap, what we will be doing here is that the time complexity will reduce around log of k and the space complexity would be big O of k. So let's see how can we do min-heap here, like how can we implement it. So let's say we have taken, or we can say we have declared a min-heap for this. So let's say we have given k equal to 3. Let's take the same example. So in the min-heap, what we will do, we will add the elements until k times. Alright, so let's say we add first 4 into our min-heap. So let's add 4. Now we have 5. Let's add 5 into our min-heap. Let me name it min-heap here. Min-heap, yeah. So we have added 4 into our min-heap. Then we have added 5 into our min-heap because the number of elements in min-heap is less than k right now. So now add 8 into our min-heap. So let's say add, now it is equal to k. Now let's add 2. Now when we have added 2 into our min-heap, it has beyond our, it is on the size is more than k. That's why what we will do, we will just pop out the element. So in the min-heap, what will happen, it will remove the least element, or we can say minimum element out of this array. So the minimum element out of this array is 2, so it will just pop out from here, and min-heap will be something like 8, 5 and 4. Alright, now let's add 3 into our min-heap. So when we will add 3 into our min-heap, so let's check k. K is less than the size of the min-heap. So we will just pop out 3 from here. That is the minimum value of min-heap. It will always contain at the top of the min-heap. So we will just remove it from here and we will return the top of the min-heap, that is 4. So we will returning 4 in this case. Similarly, we can do for another cases too, like if we add 5 into our min-heap. Let's say we are adding 5 into our min-heap. So the min-heap will become something like 8, 5, 5 and 4. So 4 will come at the top. Now the size of the min-heap is 4 and k is 3. So what we will do, we will just remove, or we can say we will just pop out the element from the min-heap. Now the size is equal to k, so we will just return the topmost element from the min-heap. So the topmost element is 5, so we will return 5 in this case. Similarly, we can do for other case. Let's see. Next case is 10. So let's add 10 into our min-heap. So we are adding 10 here. So after adding 10 into our min-heap, or we can say after pushing it into our min-heap, the min-heap will become something like 10, 8, 5 and 5. Now the size of the min-heap is 4. So we will just pop out the least element or the smallest element from the min-heap will be present acting at the top of the min-heap. So we will just pop out 5 from here. Now the size of the min-heap is equal to k, so it will just return the topmost element from here, that is 5. So 5 is written from here. Let's see next example. Next is 9. So let's push 9 into our min-heap. Min-heap will become something like 10, 9, 8 and 5. Now 5 will be popped out from here and 8 will be written from this function. So we'll be returning 8 here. Let's see for the next example. Next example is 4. So in the next case we have added 4. 4 is least, so just pop it out from here and return 8. I hope the approach is clear to you. The time complexity will be around log of k, because this min-heap will take around log in time complexity, and space complexity will be around big O of k, because the min-heap will be storing at most k element into it. So I hope the approach is clear to you. Let's quickly code it up. So let's initialize a min-heap here. So priority q int vector of int greater int q. Yeah, now let's initialize an integer size. We'll be storing the k value which we will be using in this function. That's why we are using size here. We are taking size here. Alright, so now let's store k into our size and let's push elements into our given what we can say in the priority queue, or we can say in the minimum heap. So let's push element to our minimum heap. So min-heap. So let's run a for loop auto x nums and let's push it into our min-heap. So pq dot push x, and if pq dot size is greater than 3, or we can say is greater than k, then what we will do, we will just pop out from here. So pq dot pop. I think this is fine for this. Now let's check, like let's directly push into our, let's pull q dot push value. So now check if pq dot size is greater than our size, then we will just pop out from here and return pq dot top. Alright, I hope it should be fine. Let's just run it. Yeah, it's working fine. Let's just submit it. Yeah, it's working fine. So let's calculate the time and space complexity of our solution. So the time complexity of our solution is big O of log of k, or we can say log of n. So because this priority q will take around log and time complexity, and space complexity is big O of k, because this priority queue will store at most k element into it, or we can say time complexity will be big O of n. So will be altogether is big O of n, because while traversing through all the elements of the nums array, it will take around big O of n time complexity. So I hope the approach and solution is clear to you. If you still have a doubt in this question, feel free to comment down. Please like this video and subscribe to our channel. Thank you.